So, all right. So what we're gonna do is, some people says I want to know how to do the K problem, and since you guys are not here, the rest of the problem for the K problem is also part of your homework today. I'll write it down. I'll handwrite it for you, so that way you can have extra practice. But the K problem, we're just gonna go to the 65. The one in 65 is probably the hardest one, so we're just gonna go to that in particular. So 65 has a K problem. So it's f of x is equal to k over x. And you got y is equal to negative 3 over 4x plus 3. Now, so the tangent line, conceptually, this is what you need to understand. Conceptually is, if I have something is tangent line to each other, so for example, this line is tangent, like this, two things happen. One is the coordinate are the same. So one is they have the same output. Same output. Output. And the second thing is same slope.
When you say output, do you mean coordinate?
Yeah, same output or coordinate. So you can think about it as coordinate.
I have another question.
Yep.
What was it? Was it I can't remember if it was. I think it was a bunny or someone was like eating lettuce.
Oh yeah.
That was so confusing.
Oh yeah, I saw that. Yeah.
I was trying to figure out K and like.
What happened?
No, I usually put a bunny on my OBS. It's just because I'm waiting for student to do a problem, and I just want something to relax you.
Oh.
But
I wasn't expecting any editing in the video, so like that just threw me off.
no, it's for me. It's like I have already saved inside my OBS, so I'm sorry, it wasn't meant to cause you confusion. I'm sorry. Same slope. So it has a same slope. I'm glad you saw the bunny. That's my bunny, actually. Yeah.
Wow.
My son's bunny, actually. I hate a pet. I'm not a pet person, but actually, like, I found the bunny is very relaxing, because honestly, they shit everywhere, which drives me crazy. But besides the fact that they actually very cute. They're actually very cute. But now he knows to, do his business in one spot, which is okay. So we just had to clean that spot.
And you eat everything, including the carpet.
So they have the same slope, but ideally is I always approach slope first because slope will be easier because you eliminate a lot of things. So what I'm gonna do, same slope means the derivative is gonna be the same. Does that make sense? Derivative is gonna be the same. So what we're gonna do is I'm gonna take a derivative of f of x. That's gonna be f prime of x. But before that, I'm gonna change that x to the negative 1. So I can take, that's gonna be negative 1 k x to the negative 2. Does that make sense? Negative k over x squared. And for this one, for the y prime, I'm gonna do is take a derivative of negative 3 over 4x, which is gonna be negative 3 over 4. So since they are the same, so same slope, can I just take those two and equal to each other? Does that make sense so far?
I thought I had to get rid of K.
Well, we're gonna do it slowly because there's a.
Sometimes you can't.
The problem is there was a system variable here, and we also have to remember we just only did 2. We had to do 1 as well. Well, how do you do 1? We had to set original equation equal to each other. So it has to be kx, right? Kx equal to negative 3 for x plus 3. So basically, you're gonna have this and this here. Now this is a very funny system equation. This has two things happening. One is were those two variables. Like I said, with the system equation, the highest level of system equation, you cannot solve by elimination. So nothing you can solve by elimination here. The only way is substitution. So what I'm going to do is the substitution is I'm going to go ahead and solve the easier variable. Here I don't want to solve for x squared, just because I think k is a better variable to solve for. So I'm going to get rid of both sides by negative sign, so it'll be k over x squared equal to 3 over 4. So k is equal to 3 over 4 times x squared on both sides. So I move x squared to the both sides. So k is going to be that. So I'm going to substitute this k into here. So that means 3 over 4 x squared times 1 over x. Does that make sense? Is equal to negative 3 over 4x plus 3. Then the x is going to cancel out. So that's going to be 3 over 4x is equal to negative 3 over 4x plus 3. And then move to the other side. It's going to be 6 over 4x is equal to 3. Simplify 3 over 2x equal to 3. Multiply both sides by 2. So it'll be 3x is equal to 6. X equal to 3, I believe. 2, I can't divide. What an idiot. X is equal to 2. See, I make mistake. Did you say it's okay? X equal to 2. Then you're going to plug this 2 into here. So k is equal to 3 over 4 times 2 squared, which is 4. So k is equal to 3. And yes, what is the cool thing is this though? What the cool thing is this. I want to show you on the actual graph because I wish I would show you other period, but other period I ran out of time. So this period has some extra time. So we're going to show you what happened on the actual graph. So is that okay before I move on? Daniela, you have any questions?
No, I'm just copying.
Okay. Derek, you understand? Zach? Ethan Miser? You good? Okay, Tyson, Zach? Yeah? Ferris? Good? Okay. So what I'm going to do is, you can take a picture of that. Daniela, or you, no man, you can do it later. So can I go to a different screen to show you what happened? Okay, so I'm going to go to a different screen to show you what actually happened here, which is so, I think is really cool as you get, oh crap, I just get rid of one equation I really need. So I'm going to plug in this one. I'm going to say k over x. So I'm going to say k divided by x, right? And I'm going to say y equal to that. And what's the is any restriction? No. I'm going to add a slider k. And then the other one is y equal to what? Negative 3 over 4x and then plus 3. So now I'm going to graph both. Now if you see here, there's only one moment in time they are tangent to each other, which, yeah, there's only one moment. It's right there, right? Do you see that? So something about positive value, something about between positive 5 to maybe something. But we know the value is 3. So you should see that 3 and they are tangent to each other. Do you see that the output is actually equal to each other? And also, if you zoom in enough, you're going to see that particular point have the same slope, just like what we assume. So same slope and same output. And that's the idea you got to get. Is solving part, every question is going to be small difference. And then you just have to go back to practice a problem. But a lot of the time I told people, think about a big idea. What does a big idea mean to you? That's the most important part. Okay. So any particular questions here before I move on? Now go back and let Daniela finish copying. Robert, did that help you? It's just probably the solving the equation part is a little bit different.
Well, honestly, I probably could. In my head, I was thinking, like you have to eliminate k because in your video, the one example you did, you were able to eliminate k.
Mm-hmm.
So then you were able to like solve for x and do it like that. So I was trying to do that, and I'm like, I cannot get rid of this k.
Okay.
Are you in the group chat?
But substitution makes sense.
Yeah, so only way is elimination doesn't really work all the time. A system equation only elimination only take care of 80% of the problem, which is probably better to know is knowing how to solve 80% of the problem. But the top 10%, which is substitution, whether in physics or whether in math, substitution is going to be one of the best way to go. Yes?
What did you cross out for k equals 2 over 4 times?
It was 3 over 4 times 2 squared because they plugged in x here too. And 2 squared is 4, so they both cancel.
Oh yeah, yeah. So it's 3 over 4, and then if I plug in the x is 2, so it'll be 3 over 4 times 2 squared. So 2 squared is 4. 4 and 4 cancel out, left with 3. Good. Okay.
I feel like the sliders and gizmos help a lot with understanding.
Yeah, the visualizing. But actually, at one point, I was going to quit my job. I actually sent in my application to go work at Desmos because I'm such a big fan of it. But they didn't want to hire me. They said I wasn't smart enough.
Sorry.
I could be a good salesman for them too. Because it was funny because I was in the conference with all the AP teachers. And it was like a teacher teach for 40 years. Like, she's really good too. So I told him about my school. The school I teach at we cannot afford a calculator. We just can't. People barely like. If I offer the only way I can get student to tutoring is I offer free food. I offer free food and everybody show up. But I hear that if I offer free food, nobody will show up because everybody's wealthy enough to earn their own food. You'll come, but yeah. So back then I had to pretty much buy pizza. Sometimes people come pizza, I'll do things. Yeah. So I applied a job over there, and they just like, yeah, you're not smart enough because they want a really smart people. But I was gonna be a salesman. So anyway, I was in this conference with all the AP teachers. She's been teaching 40 years. And she's talking about you have to use calculator. I says no. I mean my school doesn't able to afford calculator, so I had to use decimal. So I show her how to use decimal, and she's like, no, you're not supposed to use decimals. You're supposed to use calculator. I says well, and I show her how powerful is it, and she switched her mind. She's like, oh wow, that's really really cool, and slider really help. Yes, yeah.
What would you sell at decimals? Because isn't decimals free?
Decimal is free. Yeah.
So what would you sell then?
You can sell it to testing companies, which is Pearson. They bought the right of decimals now. SAT eventually the computer version of SAT will use the decimal to accompany with if you're allowed to graph. And there's a lot of FSAs now. They actually give you the digital version of the scientific calculator of decimals. They actually did that. So it's still required to sell.
Oh, okay.
But they have to buy the right to use it. Yeah. So the testing company make a lot of money, so they make crap load of money.
Because the software, you can't just plug in math into a computer and expect it to graph it. It being able to graph takes a lot of advanced algorithms.
Yeah, it does. Okay, so next question. Any question for your homework that you want me to go over? The equation tangent line, maybe like I. Yes? Okay, I'll go over those. So the I was gross. So what was the question though?
Alright,
2x minus 1.
Yeah, 2x minus 1 squared over x.
x to the 3 over 2 power.
And then when x is equal to 4, right?
Yeah.
Okay, so the hard part is actually knowing how to do the math part of it. So for me, I expand the top. And I expand the top, I don't make mistakes, so I will get 4 x squared minus 4x plus 1. Some people thought it was 4x squared minus 1, but it's actually 4x squared minus 4x plus 1 over x to the 3 over 2. And then I will simplify each one by splitting. So 4x squared over x to the 3 over 2. Plus 4x to the x to the 3 over 2. Plus 1 over x to the 3 over 2. And I'll simplify each one, so it'll be 4x to the 1 half minus 4x to the negative 1 half plus x to the negative 3 over 2. Does that make sense? I didn't do any calculus yet. I did all the algebra here. I'm going to take the only calculus step I'm going to take, which is right here, is a power rule. 4 times 1/2 is equal to 2 to the negative 1/2 minus, or negative times negative is going to be positive, x to the negative 3 over 2 minus 3 over 2 x to the negative 5 over 2. So you have to be able to work through this kind of difficult stuff. So now I'm going to plug in 4. So 2 to the 4 to the negative half plus 1/2 to the 4 to the negative 3 over 2. Yes. I made a mistake?
On that second part, you left out the 4 from the original equation. You took the
You're right.
1/2 down.
Thank you. So, see, mistakes happen. Minus 4. And there was a 4 here, right? And minus 3 over 2 to the 4 to the negative 5 over 2. So that's equal to 2 times 1 over 2. Plus this one's going to be 2 times 1 over 8, I believe. Minus 3 over 2 times 1 over 32. So 2 cancel out, 1 plus 1 over 4. Did I mess up this? Sign is fine, right? Whereas the last one is plus, right? No, it was a plus, but changed to negative, yeah. So
17.5 and 4.
so this one is gonna be minus 3 over 64.
Sorry, what's between around the it was the last line where you wrote f prime and 4. What's between the middle term?
1/2 and 4th. 1/2 and 4th. Because I have to take it a 4, and I take it negative 1/2, and it's gonna be, it becomes positive. Negative times negative becomes positive. So that's one that's gonna be 64 over 64 plus 16 over 4 minus 3 over 64. So that's equal to 77 over 64. Is that right?
It's supposed to be 64 or 16 over
16 over 64, yeah. Then, now I'm going to go back and figure out what is F4 is. 4 is going to be 2 times 4 minus 1, and then square over 4 to the 3 over 2. So that's equal to 8 minus 1, 7 square over 8. So it'll be 49 over 8. So it'll be y minus 49 over 8 is equal to 77 over 64 times x minus 4. And that would be equation tangent line here. Equation of the normal line is going to be 49 over 8 is equal to 64 over 77 negative of x minus 4. And that's going to be a normal. And this is a tangent. And that's the work I will show to get an answer. But yeah, so tedious math, we had to be able to work through it.
Helps being calm.
It helped being calm. Yeah.
Oh,
Yes.
I think it's
And yet, obviously, I make mistake without Robert's help. Then I probably will screw up the 4 and it will mess up everything. So actually, I would do it like one line, kind of double check my work, and one line to double check my work. I usually do that, but today I forgot to do that. I'm kind of hungry, so I'm kind of like.
So will we learn the basics for like 3 and 4 later? That the derivative of sine is cosine x.
Yeah. So that part is basically, I'm just gonna write down derivative. Yeah, so you want to write down derivative of sine of x is equal to cosine of x. There is a proof for that, but I don't want to show you. It's actually just definition of derivative and plug in the sine with the trig limits. But I don't have time to show you. But I'll do it when I have time, when we have extra time. But yeah, it's actually pretty easy. So with that, it's gonna give you that. And for example number 3, you should get 7 pi over 6 as the answer, and 11 pi over 6. And number 4, you should get pi over 4 and 3 pi over 4. So that should be the answer. But anyway, that was a very simple derivative, so they're not something hard.
See, for number 4 is 4 and 3 pi over 4?
Number 4 is 3 pi over 4 and pi over 4.
Okay.
So memorize these?
Yeah, let's memorize. We got a lot more to memorize. We got sine, cosine, tangent, secant, cosecant, cosecant, secant. Don't worry, there's a funny way to memorize.
I don't know what there's in class.
How much time I have?
You have around 6 minutes.
7 minutes. So we're going to talk about last question. The last question is, I want to find A and B where f is differentiable everywhere. Everywhere. So, and this is the function f of x is equal to ax to the third when x less than 2, and x squared plus b when x greater than 2. So the rule of this is make sure that they are differentiable. But remember the pyramid I gave it to you. Draw the pyramid. Do you remember that?
Draw the what?
On the top of the pyramid says
A pyramid.
limit x approach to a from the left of f prime of x has to equal to limit x approach to a prime, a from the positive, of f prime of x. Do you remember that? That the slope on the left had to equal slope on the right to make a functional roller coaster. Do you guys remember that?
You showed us your notes, right?
Huh?
You showed us your notes and like that had that.
Yeah. So they have to equal to each other. Remember, you can have slope like this, then your roller coaster is not going to be end pretty. You can slope like this, it's not going to end pretty. But you can something like bend like this, it's fine. Something is completely smooth from one finger to the other finger, and that roller coaster can move up like this, then that's fine. Does that make sense? But they have to be continuous as well. So the x approach to a from the left of f of x has to equal the limit x approach to a of right. So they have to be continuous and slope has to be the same simultaneously. Are we okay here? Now, where's the breaking part? At x equal to what? 2. So x equal to 2, that's where the breaking part happened. So let's show you what happened like this. So ax cubed, right? So I'm going to type in ax cubed here. And we're going to say y equal to that. And we're going to say when x is less than 2. I'm going to do a restriction. And the x less than 2.
So that's how you do that.
And we're going to add a slider. And so less than 2. So they don't have anything more than that, right? And I have x squared plus b. And I'm going to do y equal to, so that way I can see it better. And also some type of restriction of x greater than 2. Right? So if you let it play, right? So even I connected, right? Even I connected here. Do you think that's okay?
No. Well,
No, it's not okay because there is no small change, right? The slope is still not okay. Even I connected. That just say if somehow I make it a connect, I don't think there's going to be a roller coaster you want to ride on because still going to be off track.
it's super steep.
Yeah, it's really steep. I mean, maybe you ride it from one side to the other side, maybe from the right side to the left side. But if you have the same momentum, by the black line's finish, you're probably going to be out of track already. So that's not something you want to do. Does that make sense?
Would something like that result in like an infinite rate of change at that point?
It's not infinite. It's gonna be pretty steep though. It's gonna be like 100 of slope.
But it is like definable?
It's definable. I hear it's still definable. Yeah. So then you say, well, let's go approach like this, and that's approach from both ends. And let's just say if I have limit x approach to a, which a is on the left side, so 2 from the left side. And I'm going to take a derivative of this, so f prime of x is going to be 3a x squared. Does that make sense? When x is less than 2. So it'll be 3a x squared. Am I doing okay? And it's equal to derivative of this side, it's going to be 2x plus 0 when x is greater than 2. So it'll be limit x approach to 2 from the positive of 2x. So can I just plug in 2? So 3a times 2 squared is equal to 4. So a is equal to 1 over 3. Does that make sense? I plug in 2 on this side, a equal to 1 over 3. I'm going to set the equation equal to each other with 2 from the left of original function, which is ax cubed, is equal to limit x approach to 2 from the positive side of x squared plus b. So I'm going to plug in 1/3 in there, and I'm plugging 2 in there. I'm going to plug in x squared, which is 4 plus b. Guess what? That's going to give you 4. Nope. 8 over 3 is equal to 4 plus b. So b is equal to negative 4 over 3.
For B, did it go away because you took the derivative?
Yes, b is a constant. So if I take a derivative of a constant, they go to 0. So first of all, I set the derivative equal to each other, and I solve for it. Now, hold on a second. Before you go, I want to show you here. I want to show you the magic happen. So this is a 1 over 3, right? And this one is, we're going to let it play out and let's see here. So go back to negative 4 over 3. Look at this. Yeah, you will ride this. If it's completely smooth, you're not going to die in this case.
Sorry, could you go back to the work again?
Yeah, go back to the work. And that's on the video so that way you can see it.
What was the point of putting it in terms of
The
what
limits?
was the point of f of prime? F prime.
Because the slope has to be the same. If imagine one side slopes 2 and one side is negative 2, then you're going to have a slope like this, and you don't, look at me. The slope like this, that's not pretty.
Oh, okay.
So you want the slope to be like completely smooth from one side to the other side.